Welcome students. Welcome again to my another new lecture. I am Muhammad Thanbir Ahmed, lecturer, Department of Civil Engineering, World University of Bangladesh. Outline of the lecture. In this lecture, we will discuss about factors affecting workability of concrete, admixtures, shuttering or formworks, ferrocement concrete, and curing and its method. Workability. The term workability indicated the ease or difficulty with which the concrete is handled, transported, and placed. The amount of water present in the concrete should be in the proper ratio. The factors those affect the workability of concrete are fineness, shape, size, and gradation of aggregate, water-cement ratio, cement content, water content, temperature, mixture proportion, material used, time after mixing, air entrainment, use of water-reducing admixtures such as superplasticizer. Chemical admixture. In concrete or mortar, a substance other than aggregate, cement or water added in a small quantity, normally less than 5% of the weight of the cement, to alter the properties of the mix of the hardened solid is called chemical admixtures. So, chemical admixtures are the ingredients in concrete other than Portland cement, water and aggregate that are added to the mix immediately before or during mixing. Producers use admixtures primarily to reduce the cost of concrete construction, to modify the properties of hardened concrete, to ensure the quality of concrete during mixing, transporting, placing and curing, and to overcome certain emergencies during concrete operations. Types of chemical admixtures: water reducing admixtures, retarding admixtures, accelerating, water reducing and retarding admixtures, water reducing and accelerating, high-range water reducing or superplasticizing admixtures, air entraining chemical admixture, air entraining and water reducing chemical admixture. Superplasticizer. Superplasticizers are admixtures for concrete, which are added in order to reduce the water content in a mixture or to slow the setting rate of the concrete while retaining the flowing properties of a concrete mixture. When water is mixed with cement, some water entrapped between cement particles and therefore reduces the amount of water to give workability to concrete. Superplasticizers disperses the cement particles, improper workability. It is possible to make a vibration-free concrete with the use of superplasticizer. For a very congested layout of reinforcement, it is wise to use superplasticizer to make a flowable concrete. Superplasticizers are additives used in making high-strength concrete. Plasticizers are chemical compounds that enable the production of concrete with approximately 15% less water content. By using superplasticizer, we can get workable concrete, also high-strength concrete, and durable concrete. Superplasticizer is a chemical admixture, also known as high water reducing admixture. The dose of superplasticizer will depend on the cement content. Generally, 8 to 15 milliliter of superplasticizer is required for 1 kg of cement, and it is expressed as what of superplasticizers of per kg of cement is required. Shuttering or formwork. It is a temporary structure used as a mold to cast the member of the structure to record shape and size by laying concrete in it. Shuttering or formwork is the term used for temporary timber, plywood, metal, or other material used to provide support to wet concrete mix till it gets strength for self-support. It provides support to horizontal, vertical, and inclined surface, or also provides support to cast concrete according to required shape and size. The formwork also produces a desired finished concrete surface. Formwork should be smooth and uniform, correct dimensions, watertight, cheap, easily available, and reusable. Timber is commonly used in Bangladesh for shuttering because it is cheap, light, and available, and has sufficient strength. However, steel shuttering are recently used in urban areas. Shuttering is removed after sufficient time so that concrete can take its own load. Shuttering or formwork should be strong enough to support the weight of wet concrete mix and the pressure for placing and compacting concrete inside or on the top of the formwork or shuttering. Approximate time to remove formworks. The removal of formwork should be carried out only after the time when concrete has gained sufficient strength, at least twice the stress to which the concrete may be subjected to when the formworks are removed. It is also necessary to ensure the stability of the remaining formwork during formwork removal. The removal time of formwork for short beams, walls, columns and roofs are 10 to 14 days for ordinary Portland cement and 6 to 9 days for rapid hardening Portland cement. For long beam, it is 14 to 22 days for ordinary Portland cement and 10 to 16 days for rapid hardening Portland cement. The rate of hardening of concrete or the concrete strength depends on temperature and affects the formwork removal time. For example, time required for removal of concrete in winter will be more than the time required during summer. Ferrocement. Ferrocement is a special type of concrete made of cement, sand and water. In ferrocement, generally coarse aggregates are not used. The thickness of ferrocement concrete ranges from 20 to 30 mm. Uses of ferrocement. Ferrocement is used in the preparation of water tank, shed, boat, sculpture, etc. Advantages of using ferrocement. Ferrocement is light in weight, it is economical, durable, and it gives a better appearance. Disadvantages of ferrocement. It requires careful curing. It is labor intensive and the progress of work becomes slow by using ferrocement. We have to curing ferrocement concrete carefully because of its small thickness and small diameter of steel. Entrapped air. It is intentional void of concrete. It should be removed from concrete. The diameter of this bubble may vary from 0.5 mm to 10 mm. Entrained air. Entrained air in concrete is defined as air intentionally incorporated by means of a suitable agent. This air should be clearly distinguished from accidentally entrapped air. The diameter of this bubble vary from 100 micrometer to 0.5 mm. Curing. Curing promotes the hydration of cement by controlling temperature and moisture movement from and into the concrete. More specifically, curing keeps concrete saturated so that hydration of cement can take place in a suitable environment. Hydration at a maximum rate can proceed only under condition of saturation. So, curing of concrete is a method by which the concrete is protected against loss of moisture required for hydration and kept within the recommended temperature range. Curing will increase the strength and decrease the permeability of hardened concrete. Curing is also helps in mitigating thermal and plastic cracks, which can severely impact durability of structures. Evaporation of water from concrete surface will depend on temperature, wind velocity, and humidity. Methods of curing. Methods of curing depends on the condition, size, shape, and position of the concrete member. If surface to volume ratio of concrete is small, oiling or wetting the formwork before casting can be sufficient. Formwork may also be wetted during hardening and after removed of formworks. The concrete should be sprayed with water and warped with the polythene sheets or any other covering material. If surface to volume ratio large, loss of water should be prevented to avoid drying shrinkage. Polythene sheet should be used to prevent quick water loss. This prevention is required for dry weather, and it also protects the concrete from rainwater. Wet curing can be provided by spraying or ponding with water or by covering with concrete by wet sand, earth, sawdust, straw, cotton, etc. Period of curing. It will normally depends on the types of cement used. The minimum period of curing concrete to attain maximum strength is 28 days. From various experiments, it is now clear that the concrete attained 50% of its design strength when it cured for 3 to 7 days. 75% of the compressive strength achieved in 14 days. 90% of the concrete design strength achieved in 28 days. So it is clear, as time increases, the concrete strength also increases. Influence of curing temperature on strength of concrete. A rise in temperature speeds up the chemical reaction of hydration and helps to develop earlier strength. It also be observed that a high temperature creates a porous microstructure and thereby reduce the durability performance. That is the end of our today's lecture. Thank you everyone.